Okay, so we will continue to talk about the polar coordinates. So we will plot the points in the polar coordinate system, and we might find multiple sets of polar coordinates for a given point. And we convert polar to rectangular coordinates and convert it rectangular to polar coordinates, and also convert equation from rectangular to polar coordinates and from polar to rectangular coordinates. Okay, so what is a polar coordinate system? So we will have a pole here, and we also have a polar axis. It looks like the x-axis before, yeah, so it only has the x-axis, and so the end point is called the pole here, and then a point on the polar coordinate system is represented by ordered pair. Okay, so what is the ordered pair? P is what? R theta. So what is R here means? R is a directed distance from the pole to P. Directed means you have the sign, okay? So if from the pole to here, it will be, you get a directed distance, okay? You can be positive or negative. So that's very important for the polar coordinate. Theta is an angle from the polar axis to the line segment from the pole to P. Okay, so the line segment, it used to be in the angle, it can also be what terminal side, yeah. So it's similar to the terminal side, but here it's only a line segment because it will not go forever. Okay, so this is the polar coordinate, and here is the same. Positive angle are counterclockwise. Polar coordinate positive angles are counterclockwise. Negative angles are clockwise. Okay. So, for example, how could you plot 3 and 3 115 degrees, 315 degrees? So what will you do first? Okay, so first you will find the angle. So it's positive, and then you draw the angle 315 degrees right here, and then you draw the thing, goes forever, but then you wanted what? R equal to 3. So a directed is from the pole to the pole. Do you remember? It's is from the pole to P, yeah. So from the pole to P here. So if here is P, so this distance must be what? 3. So this point here is 315 degrees. Yeah. Okay. Although the picture does not look good here. Okay. So the next example, and we wanted to plot the points with what? Negative. Okay, so negative R here. Okay, so negative R here. So what will we do first? First, we will find the angle. So it's pi. Okay, so then what should we do? We found the distance, yeah? So the distance here is 2. So what is this angle? What is this point? This is what? 2 pi. Okay, so it will be what? 2 pi. Okay, so I will draw it. Okay. I think, the picture here didn't draw so well here. So pi is from here to here, yeah? So this is pi. And because we wanted the segment to be what? 2. Okay, so here. So this point is what? 2 pi. Yeah? So what should we do if we have r is equal to -2? So -1, negative sign, what will we do? We plot the point going out to opposite the terminal side of the theta. Okay, so it will be opposite of the angle theta. Okay, so it's a long distance, but we only need to remember it will be opposite. So what does this mean? So if it goes this way, this is 2 pi. What it will be? Instead of going this, we will go to the right side. Okay, so we just follow the direction of the theta. So because theta is right here, yeah? So we just follow this line to the other side. Okay, so it will be -2 pi. This is how you get it. This is how you get it. Okay, so I think what I will do. What I will do is I will insert a blank page and show you the next example before, without the notes. Okay, so what will we do? We wanted to graph -1, -pi/2. So first thing, what should we do? So this is the pole. This is the polar axis. Yeah, so -pi/2, you go what? Clockwise. So it's going right here. Yeah, so this is -pi/2. And then you choose 1 here. So what is this point? It's 1 -pi/2. You with me? So this point is 1 -pi/2. What do we want here? We wanted what? -1 -pi/2. What will we do? Instead of going this direction, we will go to the opposite. Okay, so here it will be -1 -pi/2. You guys clear? So this will be the like a definition and how you draw this picture. Okay, so because the picture does not look so good here, so I wanted to draw one good for you. Okay, and then similarly, what will we do? So first we will draw the angle first. So pi/4, and then you choose what? 5 on here. Okay, and which r is what? Positive. Okay, so we wanted to find another one. So we wanted r is positive, means you keep the positive, the same thing. But theta is what? 2 pi bigger than 2 pi and less than 4 pi. What should we do? We wanted the same terminal side, yeah? So then you make it one more revolution. So it's pi/4 plus 2 pi. With me? So what will you have? It's 5 pi/4 is 9 pi/4. Yeah. And similarly, if you wanted angle -2 pi less than theta less than 0, what do you want? You want r bigger than 0. What do you want then? You keep 5. What do you want in the angle? Instead of plus 2 pi, what do you want? Minus 2 pi. So you have what? 5 and then pi/4 minus 8 pi. So it's 5 -7 pi/4. With me? Okay, so this is this one. Okay, so then the next one we wanted to stay the same angle, but your r is negative. Yeah, so what will happen if your r is negative? Okay, so what will you do? R is negative. Do not forget what it will happen. It will be what? Right here, yeah? So this is what? Negative 5 pi over 4, yeah? Yeah, so because this is 5 pi over 4, and this will be what? Negative 5 pi over 4, yeah? Okay, so then what should we do? Because we wanted this point, yeah? And if your 5 become what? Negative 5, it will be right here. Okay, so we cannot keep the same angle anymore. And how could you come here? How could you make this point come here? So we can keep it negative 5, yeah? But what do you need to do? Plus what? Pi. So it means, because this is pi, yeah? So pi plus what? Pi over 4. It will be what? Negative 5 pi over 4. You guys clear? Okay, so what is the formula here? If your r change to what? Negative r, what will be your theta? Your theta will be theta plus pi or theta minus pi, depending on what? Which kind of theta you want. Okay, which theta you want. Because your r goes to negative r, then you are changing the angle. You plus pi or minus pi. Okay, so this is the formula. Okay, and I think we did this one already. We have already practiced this one. This one is gone. Okay, so now we wanted to think about this with polar coordinates with what? Rectangular coordinates. So polar coordinate is what? R theta. So theta is this. R is the directed segment, yeah? Directed segment from pole to the point, yeah? Okay, so what will be the x value then? X equal to R times cosine, yeah? Yeah, so cosine is adjacent over R, yeah? And sine is what? Is opposite over R. So cosine theta equal to what? X over R. Sine theta equal to what? Y over R. So then you will get this, yeah? Okay, so then what else do we know? X squared plus Y squared equal to R cosine squared plus what? R sine theta squared. Okay, so what will it be? R squared cosine squared plus what? R squared sine squared. So what do you have? R squared times cosine squared plus sine squared. Cosine squared plus sine squared is what? 1. Yeah, so that's a famous identity. So you have what? R squared. This is how you get it. But there is an easier way to do this. What is this? Pythagorean theorem, yeah? Two sides square plus equal to the hypotenuse square. Okay, so I also prove this using the identities. At tangent theta, what will be tangent? It's always opposite over hypotenuse, y over x. Okay, so these are the relations between polar and rectangular coordinates. Okay, so then how could you convert? Yeah, so then you have already know from polar coordinate to rectangular, you have to use what? X equal to R cosine, Y equal to R sine. And then from rectangular to polar, you will use the second. X squared plus Y squared equal to R squared, tangent theta equal to Y over X. Okay, so then what should we do here? So here, if we have the polar coordinates, this is R, this is theta, yeah? And then what will you have? R cosine theta, 3 cosine pi. Cosine pi is what? Negative 1. And sine pi is what? 0. So we have negative 3, 0. Okay, so negative 3, 0. Okay, good. Okay, so then we have the polar coordinates is what? Negative 10 pi over 6. So negative 10 times cosine pi over 6 is negative 5 square root of 3. Negative 5, so you have cosine pi over 6, you should know, yeah. And that is square root of 3 over 2. Okay? Okay. Okay, so the next one is the point conversion from rectangular to polar. Okay, so what should we do from rectangular to the polar? We have to use, so where does this thing come from? It's r squared is what? X squared plus y squared, yeah? And then what happens here? Then r will be equal to square root of x squared plus y squared. So the theta, what will you do? Okay, so the tangent theta equal to y over x. What will be theta? Tangent inverse, yeah? So you have to use what? Tangent inverse with terminal side theta passing through this, okay? Okay, now let's look at this question. Okay, so there is a tricky one. Okay, so from polar to rectangular, okay, coordinates. So you always need to define which quadrant is of the point. Okay, so quadrant of the point will be super important. Okay, so because it will determine which angle you choose here. Okay, so because when you do r, what do you have? Square root of x squared plus y squared. So this is your x, this is your y. You always keep r equal to 2. Because you only keep r is positive here. So the quadrant of the point will be super important. Okay, so that will be the next one. So tangent theta equal to y over x. Tangent theta equal to y over x. Tangent theta equal to negative square root of 3. Okay, so tangent theta equal negative square root of 3. But how could you know that theta equal to 5 pi over 2? So because tangent equal to negative, which quadrant it could be? It has to be what? Quadrant 2 or 4. Yeah, but so 1 comma negative square root of 3, this is in quadrant what? 4. So which quadrant you should choose? Quadrant 4. Okay, quadrant 4 here. Okay, so then how could you find this? Then what is the reference angle? Reference angle theta prime is what? Tangent inverse of the positive part. Yeah, so reference angle is always acute. So that is what? Pi over 3. Then because in the quadrant 4, what will be your theta? You always 2 pi minus the reference, yeah? So it's 2 pi minus what? Pi over 3. That is what? 5 pi over 3. This is how you get the 5 pi over 3, okay? Be super careful. Be super careful. Okay? Okay, I think they didn't emphasize here, but when you do it, be super careful. You should know how to do it. Okay, so this is the final answer. So then the next thing we wanted to do is convert the equations from rectangular to polar and polar to rectangular. Okay, so what will we do? It's the same thing, yeah? So 3x minus y equal to 6. We wanted to the polar coordinate. What is x again? Your x is what? R cosine. Your y equal to what? R sine. Substitute. What will you get? 3r cosine minus r sine. And what will you do? You get the r out because r is in common. Then you get this. Yeah, so you make it r equal to something. That is the final form. Okay? Yeah, okay. So the next one. Okay, so the same thing, you use what? X equal to R cosine, Y equal to R sine. So this one is a little bit more complicated because when you have to what? Completing the square, yeah, you have to FOIL here. Do not distribute, you have to FOIL. So R square cosine square, R square sine square plus the middle term, yeah. This is super important, plus 2R sine theta plus 1 equal to 1. Yeah, so when you see cosine square, when you see sine square, combine them together. That's 1, yeah? So it's R squared plus 2R sine theta plus 1 equal to 0. So R squared plus 2R sine theta equal to 0. Yeah? Okay, 1 cancel. So what do we need to do? You factor the R out. Then two things multiplied together equal to 0. What does this mean? Each part equal to 0. R equal to 0 or R plus 2 sine theta equal to 0. Okay, so R equal to 0 or R equal to what? Negative 2 sine theta. Okay, because this is what? A circle, yeah? What is your radius here? Oh, what R, put R be 0 here? No, yeah? So R cannot be 0 here. So, yeah, so because if it's 0, no, it will be a dot, yeah? So R, we wanted to choose is what? Negative 2 sine theta. Okay, so this is this. Okay, so then the next thing we wanted to convert what? The polar. Yeah, so this convert the polar to rectangular. Okay, so then what should we do? R equal to 4, okay? R equal to 4. Do we have a equation with R directly? Unfortunately not. So what will we do? We wanted what? Because we know the only thing we know is R squared plus equal to X squared plus Y squared, yeah? So what will we do? We wanted to relate it with xy. So we wanted to square both sides. You have R squared equal to what? 16. What will you have here? It will be X squared plus Y squared equal to what? 16. This will be what? Polar one. Rectangular coordinates. Okay. So the next one is a tricky one, yeah? So we know that, theta, if we are given theta equal to 3 pi over 4, yeah? But, in the polar coordinates, what do we know? We only know tangent theta equal to y over x, yeah? If theta equals 3 pi over 4, what do we know? Is tangent of what? 3 pi over 4 must be equal to y over x, must be equal to what? Negative 1, yeah? So what do we have here? Y over x equal to negative 1, then y equal to what? Negative x. Yeah? So in the polar coordinates, for if theta equal to a constant, that's a line. So theta equal to a constant, it will be a line. And r equal to a constant, what it will be? It's a circle. Okay, so these are the two special graphs. These are the two special graphs. Okay, so then we wanted to do more. Okay, so for this one, r equal to negative 2 secant theta. Yeah, so what do we know? Yeah, so we wanted x and y. Yeah, x will be r cosine, y equal to r sine. This is what we know. Yeah. Okay, we do not have r times cosine, and we do not like secant either. So what will we do? Could we relate secant with sine or cosine? Yes. So negative 2 cosine. It's on the denominator. We wanted to what? See, we multiply on the other side, negative 2. So r cosine, this is we are familiar with. So x equal negative 2. Good, then it's done. Okay, r equal to 10 sine theta. Okay, so this is another one. Okay, r equal to 10 sine theta. Okay, so what should we do here? What do we want? We want what? R sine theta equal to y times r, then that's perfect. But if we have r on this side, that's not what we want, yeah? Okay, then what should we do? Make one, yeah? So if we are missing something, multiply r, you multiply r on both sides. Okay, so why do we want to do this? Because we wanted to make a r sine theta that will be y, yeah? So r times r is what? R squared is 10 r sine theta. This is your y, so this is 10y. And r squared happens to be what? X squared plus y squared, yeah? Okay, so what we have is x squared plus y squared minus 10y equal to what? 0. And then you can follow this thing to find, oh, this is actually a circle. Yeah, so this is actually a circle. So this is very useful in calculus too. In calculus, okay, so later on in calculus you will know. Okay, so then, okay, so this is just draw the picture. Okay, this circle is not drawing so good, okay, but this is the books. Okay, good, that's the end of this section.